Good evening, everyone. I hope you're doing well. My name is Anne-Marie Jacob. I am an assistant professor in the Department of Psychology at Kristu Jayanti University. Today, we will be learning about t-test. Now, t-test is a statistical tool which allows you to understand whether there is a statistical difference between the means of two samples, right? Now, you have various types of t-tests. You've got one sample t-test, independent sample t-test, and paired sample t-test. The popular types are independent sample test, t-test, and paired sample t-test. Now, let's understand what do we mean by these three. So, one sample t-test, you will choose to run that when you have a hypothesized mean available to you, a hypothesized standard deviation available to you, and then you would have collected a data set from a sample, from one single sample, and then you will understand whether the difference between your sample mean and in terms of your hypothesized mean, whether that is significant or not. And as I said, you will not typically resort to a one sample t-test until and unless you have some idea about the population mean, or as I've been calling it, hypothesized population mean, where you have some inclination that this is the population mean. Only then you can compare the sample mean with the population mean. Yeah, so that is one sample t-test. Now, independent sample t-test is when, um, let's give you an example first. Say you want to study compassion fatigue or the levels of compassion fatigue between nurses and, say, teachers. And you want to see whether it is statistically significant or not. Now, what you'll do is you will employ your questionnaire, you'll gather the data from both nurses and the teachers, and you will then have two data sets. And then and you will administer the t-test, you will run the t-statistic, and you will find out whether the difference between these two means are significant or not. And so that is for independent sample t-test. When it comes to paired sample t-test, you say that, again, let's take the example of nurses, and you want to understand their stress levels. Yeah. And in a paired sample t-test, typically you would want to introduce an intervention and then see what kind of effect has it had. So how do you go about employing it? So you've got the stress test, you've administered the questionnaire around stress, you've got a certain data for that, and then you introduce an intervention, or somebody introduces an intervention. Say they are given a vacation time, or say that they incorporated yoga sessions in the organization for a certain time, let's say in the evenings for the nurses. And you do this for about a week or two, and then you check their stress levels once again. So because you're getting two different data sets from the same sample, that becomes a paired sample t-test. All right. Uh, I hope you understood. Now, again, much like any other statistic, you'll have to make hypotheses. You can form a null hypothesis or an alternate hypothesis. So null hypothesis assumes that there is no significant difference between the uh, two data set or two sample means. And an alternative hypothesis will assume that there is a statistical difference. So to put it into words, let's say in terms of compassion fatigue, our first example, a null hypothesis would state that there will be no difference between the compassion fatigue levels between the nurses and the teachers. And an alternative hypothesis will state that there will be a statistically significant difference between compassion fatigue levels of nurses versus teachers. So that is the hypothesis. I'm sure you're already familiar with null and alternate hypotheses. Now, and of course, before you start to if before you want to administer the t statistic, you have to ensure that the assumptions of parametric tests are met. You want to check whether you want to see that the data set is normally distributed, right? So for that, you can run a Kolmogorov-Smirnov test or Shapiro-Wilk test, and based on that, you can then determine whether the data is normally distributed or not. And then you want to also check that the errors are also equally distributed between both the data sets, or the variance, as in the data set is equally varied across the sample, right? So that's another thing that you have to ensure. And then another thing which I've not mentioned here is that you want the data to be on an interval or a ratio scale. You want the data to be continuous in nature so that you can administer, you can run the t-test. So that these are some things that you want to take care of. Now, so what you'll do is you will, as I already told you, you will get the sample mean for both the samples, and then you will understand, you will employ the formula, and then you will get a certain result, and then that will help you determine whether or not it is significant result, or whether it isn't a significant result. Now, these are the formulas that you have. So for a one sample t-test, as I said, it's not very popular, maybe at a very beginner level, just to familiarize you. Perhaps you can do it, but typically we resort to two sample t-test, or independent sample t-test and paired t-test. So for a t-stat, one sample t-test, this is the formula that you are looking at, x bar minus, and as I said, you are looking at a hypothesized mean. So that's why mu is being utilized here. And then standard deviation divided by n, which is also under the root. And then degrees of freedom that you use here is df equals to n minus 1. For two sample t-test, you are utilizing the mean of sample 1 minus mean of sample 2. So x bar minus 1, x bar 1 minus x bar 2 divided by, you get the standard deviations of both the first sample and the second sample, and you divide it off the square root of n1 and n2. So let's look at, and the df is n1 plus n2 minus 2. So let's look at how is it that you are going to use this, or how is it that you will employ this. Just a moment, I'll share another screen. Yes. So here we have it. Now, this is from a website called qmath.com. I just wanted to give you an example. So here we have, here's the example. Calculate a t-test for following data of the number of times people prefer coffee or tea in 5-time intervals. So you've got a certain data for coffee and then certain data for tea. Now, what you then do is, so x1 is being denoted for, x1 is being used to denote coffee, and x2 is being used to denote tea. And then what you do is, your very first, so when you would have learned about measures of central tendency and measures of variability, you are already, I hope that you're already familiar with how to calculate mean, variance, and ST. So this is the step. This is for x1. You find out the mean first, and then you subtract the mean from the observations that are listed here. And once you've done that, you square it off and you get a value. Here you've got 14.8. You do the same thing for t, or x2 in this case. You find the mean, you subtract the mean from each observation. Each observation you subtract it, you square that, and you get a certain value. And then, yeah, So this is the mean that they have found out. So 6.2 for x1, 5.6 for x2. And then, yes, this is the summated value for x1 and this is the summated value for x2. And then you find out the standard deviation for, this is standard deviation 1 and standard deviation, so 3.7 and 4.3. And then this is the formula that you're utilizing. So uh, x bar 1 minus x bar 2 upon, you've got the standard deviation values and then n1 and n2. So you apply all the values. So 6.2 minus, so these are the mean that you've got. And then you've put your standard deviation value for x1 and then standard deviation value for x2. And in both the cases, observations are 5 and then you get a value. So 0.47. Now, and then you have certain tables that you can refer to verify whether, and you, of course, you need to find the degrees of freedom. So I told you that degrees of freedom, the formula to calculate degrees of freedom is n1 minus n1 plus n2 minus 2. So in this case, n is 5 in both the cases, in both the sample set. So you do 5 plus 5 minus 2. So df will become 8. And then df will become 8. And then there are certain standardized tables. You'll go there and you look at the value, look for a value at df 8 and then p level of 0.05 and 0.01 subsequently. And you'll check whether the value, whatever value that you have there, if this value is greater than that, then you will reject the null hypothesis. Yeah. So that is essentially how you do independent sample t-test. With that, I'll stop. Thank you so much.